Hey guys, I'm going to review homework 5-4. This was all on probability. And so when we look at this, we have a couple things that we're going to look at. One is theoretical probability. So this is the possibility of something happening, or experimental probability, like we'll look at in number 2, which is based on what we've seen actually happen, and we're going to use that to predict something else. So in number 1, I have 54 possible numbers. So those are my numbers of outcomes. 54, that's my number of outcomes possible. And A says if I put $1 on number 34, so let's imagine it's a wheel and it's got numbers 1 through 54 on it, and I put $1 on 34, what's the chance that I'm going to win, right? And so I'm going to use my possible number of outcomes and the event that I'm looking for, the event, to create a fraction to express the probability of something happening. So my event is that I land on 34, and this is one thing. So there's only one way that I can win, is if I land on 34. So that means that my events are going to be 1. The options in terms of outcomes is 54. So the chance that I win my dollar back is 1 out of 54 if I only put a number on 34. Whereas in part B, if I put $1 on number 3 and on number 27, now I have 2 different events. So these are both possible events where if they happen, I could win. So this is 2 different events out of still the same total number of outcomes, out of the same chances that I could win. So 2 out of 54. I can simplify that one, if we remember, by dividing both the numerator and denominator by 2. So I could put 1 on the top and 27 on the bottom. So I have a 1 out of 27 chance of winning. Now when I drop down to step C, or part C, I have 3 events now, 4, 5, or 6. If I put $1 on 4, I put $1 on 5, and I put $1 on 6. These are my events that could happen, and there are 3 of them. So there are 3 possible ways that I could win out of the total 54 numbers available to me. And so that makes my probability 3 out of 54, which again, I could simplify. I could divide both the numerator and the denominator by 3. So 3 divided by 3 would be 1. 54 divided by 3 would be 18. And so I have a 1 out of 18 chance of winning if I put $1 on 4, 5, and 6. So notice, as I have more events, my probability of winning gets better. I have 1 over 54, 2 over 54, 3 over 54. So, I think as we kind of understand, just logically, I have the greatest chance of winning if I put more numbers down, but mathematically, it's 3 times as much. 3 out of 54, 1 out of 18. So in number 2, it says, over the course of the month, we keep track of how accurate the weather forecast was. And so we took a look and we found that 22 out of 30 days, it was correct. And so we want a probability to reflect how accurate this experiment was, or how accurate the probability was that the weatherman was correct. So it was 22 out of 30 possible outcomes, 22 events that they were correct out of 30 possible outcomes, 22 out of 30. And it says express it as a decimal. And so if I put that into a calculator, we remember how to go from decimals or from fractions to decimals. We divide the numerator by the denominator, and so I'm going to do 22 divided by 30, and I get 0.73. And there's a repeating 3 on there, but I really only need to write down one of them. Now, if we want to take that one step further and go to percent, remember we would just move the decimal place 2 places, and I would get 73%. Was how accurate my weatherman was this month, right? And so if I want to then apply that to the number of days in a year, we want to compare the 22 out of 30 to how many days would they be correct out of 365 days. And this is something we're going to work on more, proportions, but I want to kind of take the probability that I found and apply that to 365 days. So we're going to look at how to do it this way later, but I'm going to start by using my decimal, my 73% or my 0.73. And so if I know that 0.73 is how often they're correct out of 365 days, I can just multiply them together. And so when I go ahead and multiply those together, I'm just going to put it in the calculator. Times 365 days, or in 1 year. This says I'm going to have 267.66 days that my weather forecast is correct. So maybe I'll round that up to 268 days, maybe give them the benefit of the doubt there. 268 days. All right, so that seems to be going fine so far. And so let's move on to problems number 3 and 4. In number 3, we're talking about a 6-sided die. And with the 6-sided die, we're really looking at theoretical probability here. However, I could take a die, and I provided a link to a simulator, if you have a die at home, to test this out. How often would I get a 2, right? But math is telling me, or probability is telling me, that I have 6 as my possible number of outcomes. I have 2 as the event that I want to happen. And so I'm going to put 6 in my denominator, and I don't want to put 2 in my numerator. 2 is just the event that would be correct, how often I would be correct, or what I would need to do in order to win, let's say. And so that's only one chance of me being right, or one chance of me being correct. So my numerator is 1. Now, in part B, what are the chances that I roll an even number? Well, a die has numbers 1, 2, 3, 4, 5, and 6. And even numbers are those numbers that are divisible by 2. So I could be correct if I rolled a 2, a 4, or a 6 as my event. So that's 3 opportunities that I have to be correct. So 3 is my numerator and 6 is my denominator. In part C, I can be correct if I roll a 5 or a 6. So these are my 2 events where I could be correct. And again, I'm going to use 6 as my denominator. That's my total number of outcomes, the possible number of things that could happen. But I want one of these 2 things to happen, a 5 or a 6. So I could be correct if I had a 5 or 6. So that's 2 different events. And so my numerator is a 2 out of 6. Now, we could simplify that 2 over 6. We remember our fractions. We could divide by 2 and divide by 2 and get 1 over 3. And with 3 over 6, we could simplify this, divide by 3, and we could have 1 over 2, or 1/2. In the last part, I have a deck of cards. If you've seen a standard deck of cards, it has 52 cards, so that's my outcomes, right? And we have, our ace. We have numbers 2 through 10. We have our jack, queen, king, right? And so there's also 4 different suits. We have diamonds. Draw a little diamond on there. We have hearts. We have clubs. That's the thing that kind of looks like a clover. I'm not a great artist there. Or we have spades. That's maybe heart-ish shaped thing. It's supposed to be like a shovel. That doesn't look very good at all. But anyway, 4 different suits, and there should be 13 cards of each suit. Right? If we do 52 cards evenly divided by 4, we should get 13. So those are just some pieces of information that might help us with these problems. So in the first one, part A, it says, what if I draw 4? That's the event that I'm looking for out of 52 possible outcomes. So we know my denominator is going to be 52. Now, we don't want to put a 4. And we don't want to put just 1, because in my deck of cards, I should have 4 4s. I should have a 4 of diamonds, a 4 of hearts, a 4 of clubs, and a 4 of spades. So I have 4 possible opportunities to be correct, so 4 out of 52. I can simplify this, right, to 2 over 26, or 1 out of 13 that I'm correct. I could draw a diamond. Now, again, my total number of options is 52. like we talked about, we're going to have 13 of each suit because we have 4 different suits, and there's an even number of each suit in our deck. So I have the opportunity to be correct 13 out of 52 times if I'm trying to draw a diamond. And so I can simplify that, right, to 1 out of 4, actually. So we can divide by 13 and divide by 13 and get 1 out of 4 options. Now, a card with an even number. So I have numbers, right? If we're not going to count any of our face cards as numbers, we could have 2, 4, 6, 8, or 10, right, as an even number. And so that's 5 cards. That's 5 events that could be correct, 5 events. But that's for each suit. So if I have 5 events of diamonds, of hearts, of clubs, and of spades, I'm going to have 5 times 4, so 20 events out of 52. I can simplify that. I could divide both of them by 4, right? So 20 divided by 4 would be 5. 52 divided by 4 would be 13. And I have a probability of 5 out of 13.